Hello everyone, welcome back to the playlist of numerical methods. In the previous videos, we have understood what is Newton's forward and backward interpolation method, and later on we have seen some practice questions based on these methods. Today we are going to discuss the MATLAB code for Newton's forward and backward interpolation method. Since we are going to code Newton's forward method first, so recalling some theory, we are always given some tabulated values of the function f corresponding to some discrete values of x, and while applying Newton's forward difference interpolation formula, we use this function phi nx. We have also seen in the practice based video of Newton's forward and backward interpolation method, we have always constructed the forward or backward difference table first. Let us firstly understand forward difference table, which is in the general form. That is, if y are y1, y2, y3, y4 and y5, then the first forward difference is like y2 minus y1, y3 minus y2, y4 minus y3, y5 minus y4, and the corresponding second difference b, let us consider this as a1, a2, a3 and a4, and I have considered these values as ai's just for the simplification purpose. So the second difference be a2 minus a1, a3 minus a2 and further a4 minus a3. Let us consider these values as b1, b2 and b3. Now the third difference be b2 minus b1, b3 minus b2, and let this be as c1 and c2. Lastly, the fourth difference will be c2 minus c1. Now let us analyze this table first. We had initially 5 values of y. So here the value of n is 5. For the next column in this table, we have 4 entries which have been reduced by 1. And in the second difference column, the values have been reduced to 3, and in the third difference, the values have been reduced to 2, and in the last, which is fourth difference, we have only one value in this column. Also, when the value of n is 5, then we will have n minus 1 forward differences. I hope this table in the general form is clear to you. We will again go through this table during the code. For the reference, I am considering the same question I have discussed in the previous video, so that you will have an idea how the code is working, and the manual solution of that question has already been discussed. The question is to fit a polynomial of degree 3 which takes these values. First of all, this code will be very similar to Lagrange interpolation MATLAB code we have discussed earlier. If you have understood that code, then you will have no problem in understanding this code. Only one additional thing will be here, that is finding the forward or backward difference table. Like in the Lagrange interpolation method, we have firstly input the data points in the form of vectors. Similarly, we will do this thing in this code. Starting the MATLAB code, using the variable x underscore values to enter x values in the form of vector, and using the variable name y underscore values to take the input from the user as a vector. When this code will run, we have to enter the x values as 3, 4, 5 and 6, and the y values will be entered as the vector 6, 24, 60 and correspondingly 120. Now to find the length of these values, n is equals to length of x underscore values. You can use either the variable x underscore values or y underscore values to find the value of n, as the dimension of x and y values are same. In Newton's forward or backward interpolation formula, we always assume that the x values are equidistant, and if they are equidistant, then we have to find their difference, that is the value of h, which will be equals to x values at index 2 minus x values at index 1. When the code will run, the value of n will here be 4 and the value of h will be 1. Since we are writing this code to find the Newton's forward or backward interpolating polynomial, so defining the symbolic variable for constructing the polynomial, and we can do this with the help of symbolic form x. Now initializing the Newton's forward interpolation polynomial to the value y naught, which is 6 here, and the value 6 is at the index 1 of y underscore values variable, that is n underscore poly is equals to y underscore values at the index 1. And when the code will run, initially this L underscore poly will have the value 6. Now we have to find the forward difference table, and one thing here should already be understood to you, that Newton's forward and backward difference table are always same. Therefore, if we are considering this code for the Newton's forward method, still the table will be same, and if we are considering this code for Newton's backward formula, still the difference table is going to be same. So firstly, we will initialize the forward difference table. diff underscore table. This is the variable name for the difference table, and this is to be initialized as zeros, whose dimension is going to be n comma n. And in the previous, when we have seen the general form of this forward or backward difference table, we have seen that this table has dimension 5 cross 5, because in total we have 5 rows, and in total, including the values of y and their forward differences, there are 5 columns. So the dimension of this table is 5 cross 5. Therefore, when we have initialized this difference table, the dimension of this table is n comma n. And we have seen that the value of n is initialized as 4 here according to the entered values of x and y. So this differential table will be of size 4 cross 4. Let me draw this table by side so that you will have this understanding too. These are the entries of difference table right now, and we will replace this column by the entries of y only. So this can be done using the statement difference table all the rows of first column. Let us understand this index first of all. Whenever we are going to have two tuple, the first entry will always be about the rows and the second entry will always be about columns. If we are using colon here, it means each and every row will be considered, and if we are mentioning the particular column number here, then only that column will be considered. So in this statement of this differential table, only this term will be considered because we have used colon comma 1. So all the rows of first column, and this will be updated as y underscore values colon, and in the code this table will be updated as 6, 24, 60 and 120. I think I have constructed this differential table as 5 cross 5, but in actual the dimension is 4 cross 4. So this will be the actual size of the difference table. Now the next thing we have to do is update this second column. For that we will use the loop for j starting from 1 and running till n minus 1, for I running from 1 till n minus j, and the difference table at index I comma j plus 1 will be updated as difference table at I plus 1 comma j index minus difference table at I comma j, and these loops will end. Let us firstly understand this loop. Till now the difference table is here written in the blue color. When the loop will be initialized, the j value is 1 and corresponding I value is again 1. And this statement says that difference table at index 1 comma 2 means first row and second column, which is this entry. This entry needs to be updated by 2 comma 1 and the index 1 comma 1. 2 comma 1 means second row first column. Second row first column means the value 24, and 1 comma 1 index means first row and first column, which is the entry 6. and we have to subtract these entries and update at index 1, 2, and this value will be updated by 18 now. After that, the value of j will be same, but the value of I have been updated as 2. And we also need to note that this loop will run till 4 minus 1, that is 3, and this loop will run till 4 minus j, and currently the value of j is 1, that is 3. Now the value of I is 2 and the difference table at index 2, 2 means second row and second column, which is this entry, and this needs to be updated by taking the difference at 3, 1 and 2, 1, which is 60 minus 24, and this value will be updated by 36 now. After that, the value of j will be again same and value of I will be 3, and the value of I will be 3. The difference table at index 3, 2, which means third row and second column, this will be updated by, means this value will be updated by the difference of I plus 1, which is 4, 1 and 3, 1, which means 120 minus 60. So this value will be 60 now. Since the for loop for the value of I run till the value of 3, so this column of difference table have been updated. Similarly, when the value of j will update, the corresponding columns will update accordingly, and the final value of this table will be, for the printing we can use display function the forward and backward table is difference underscore table, or you can also directly write difference underscore table and do not use semicolon in the end of the statement. Till now we have the values of x, the values of y's and their corresponding difference table. The next thing that we have to calculate is the polynomial, and for the polynomial, which is this, we used this as p, and when we will use these values as p, the equation will be updated as forward difference into p plus second forward difference into p minus 1 plus third difference into p minus 1 into p minus 2, and similarly this thing will be updated as nth forward difference into p minus 1, p minus 2, so on to p minus n minus 1, and the factorial term will be continued. Now in the code, firstly we will calculate the p value as x minus x naught divided by h, which will be p is equals to x minus x underscore values at index 1 divided by h. Now initializing the terms for p into p minus 1 and so on to in the polynomial, we use the variable p underscore term which is initialized as 1. Now to find the Newton's forward interpolation polynomial, we use the loop for which will start from 1 till n minus 1 and updating the terms p underscore term is equals to p underscore term into p minus I minus 1 and adding this term into the final polynomial, which will be in the form of L polynomial plus this p underscore term divided by factorial at I, and this whole thing needs to be multiplied by the difference table 1 comma I plus 1, and this loop ends. Now let us firstly understand this loop. Till now we have the forward difference table as the value of p will be variable x minus. We have used the values of x in this code as 3, 4, 5 and 6, and the corresponding y values are 6, 24, 60 and 120. And the x values at index 1 is 3, so this p value will be x minus 3, and this is divided by the value of h, which is calculated as 1. Now when the loop will initialize, the value of I will be 1, and this loop will run till 3 because the value of n is 4. Now when the value of I is 1, p term will be updated as p term into p minus I minus 1. So p term is equals to 1 into the value of p, which is x minus 3 minus the value of I is 1 minus 1, which is 0. So this value is again x minus 3, and this will be updated in L polynomial, which is already having the value 6 initialized, plus p term, which is calculated as x minus 3 divided by I factorial, which is 1 factorial, into the difference table value at first row and second column, which is 18. When the value of I will be updated as 2, then p term value will be equals to x minus 3 into p value minus I minus 1. The p value is currently again x minus 3 minus 2 minus 1, and this value is nothing but x minus 3 into x minus 4, and the polynomial value will be updated as x minus 3 into x minus 4 divided by 2 factorial into difference table value at first row and third column, which is again 18. Similarly, this loop will work for the value of I as 3 and the final polynomial will be constructed. And to simplify these polynomial in terms of x, you can use simplify function and pass this polynomial. This will simplify the final generated polynomial in terms of x, and to display this polynomial you can use the printing statements display polynomial. Do not use semicolon after that statement because that will not print the polynomial in the command window. Till now we have created our code to find the Newton's forward interpolating polynomial, and to find the value of that polynomial at some given point we can ask the user to enter the value where we want to interpret the value, and the corresponding value of y substituting using the SUBS inbuilt function in the polynomial and the corresponding variables and the variable value. You can also skip this x here because there is only one variable in n_poly, and for the printing purpose you can use the display function as well as fprintf function we have discussed in our earlier video. You can use either of the function you feel comfortable with. I hope you have made an understanding of this code. I have tried my best to explain each and every statement of this code. In the last two videos, we have always understood Newton's forward method first, and then we have converted that same theory or question into Newton's backward interpolation on the similar lines. The code for this behaves the same. I will just update this code with different color so you can understand where you have to make the modifications to convert this same code into Newton's backward interpolation formula. Firstly, we will enter the values of x, y's and find the length and h value. Till the symbolic variables it will be same, but when we will initialize Newton's backward interpolation, we will change this index as n. So n underscore polynomial will be equals to y underscore values at nth index. Since the forward and backward difference table we have already discussed is same, so these loops will be similar. But when we will use the value of p, then we will use x underscore values at nth index, not at the first index. So p is equals to x minus x values at nth index divided by h. And for the code of finding polynomial, we just have to make a little change at the difference table where we will use the index n here in place of 1 comma I plus 1. Rest everything will be same. We just have to update L polynomial, p values and in the final difference table index value. this whole code will change into Newton's backward interpolation formula. I hope you have made an understanding of this code. Try the questions we have discussed in the previous video and check if this code works correctly or not. If you still found any doubt or issue in any statement of this code, feel free to ask them in the comment sections. And if you have found this video useful and my efforts are helping you, then show some love to my videos and share it with your friends. Happy learning!